In this session, we will look at interest rate swaps, which is a widely used derivative instrument in several financial markets around the world. An interest rate swap is a transaction in which two parties agree to exchange periodic interest cash flows, fixed versus floating. It will be for a specific period of time, usually long term, 10 to 15 years duration, and for a pre-agreed notional amount. Let's look at an example for a better understanding of interest rate swaps. Let's say there are two firms, firm X, which prefers to borrow in fixed rates, and the rate it commands in the market is 10.75 if it wants to borrow fixed rate, and LIBOR plus 0.75 if it wants to borrow floating rate. And its counterparty is a firm Y who prefers a floating rate, and the rate it commands in the market, if it went for a fixed rate loan, it could get it at 10%, and if it went for a floating rate loan, it could get it at LIBOR plus 0.5%. Now, as you could see from the above table, the cost of borrowing is lower for firm Y in both the fixed rate and the floating rate market. In the fixed rate market, the difference is 0.75, and in the floating rate market 0.25. So in interest rate swap parlance, we say firm Y has absolute advantage in both markets, but firm X has comparative advantage in the floating rate market, because in the floating rate the difference is 25 basis points, in the fixed rate it is 75 basis points. The differential is 10.75 minus 10 on the fixed rate, which is 0.75, and in the LIBOR it is LIBOR plus 0.75 minus LIBOR plus 0.5. The net difference is 0.25. So 0.75 minus 0.25 would give you an effective differential of 0.50. Now, the objective of an interest rate swap is to use this benefit of 0.50 and reduce the cost of borrowing for both the parties X and Y, and make sure that X gets it at a fixed rate and Y gets it at a floating rate, and X would therefore get it at, assuming that 50 basis points are split equally between X and Y, X borrowing cost could reduce to 10.50 and Y's cost of borrowing could reduce to LIBOR plus 0.25%. Now, this might sound like magic, but let's see how this is achieved in interest rate swap. We tell firm X to borrow at what it does not like. Remember, X likes fixed rate. So when you're setting up an interest rate swap, you tell firm X to borrow floating rate from the bank. It goes to the bank that is lending and borrow at LIBOR plus 0.75. And we do the exact for firm Y. We tell firm Y to borrow fixed rate while its preference is floating rate, and it's able to borrow at 10%. So what the two firms would pay the banks, firm X, the interest rate is LIBOR plus 0.75, and firm Y, fixed rate of 10%. Now remember, our goal is to get firm X an effective borrowing cost of 10.5% and firm Y an effective borrowing cost of LIBOR plus 0.25. Now how is that achieved? By creating a set of cash flows between firm X and firm Y. How is that done? The bank that is setting up the interest rate swap, so firm X is told to pay 10.5% to firm Y, and firm Y is told pay LIBOR plus 0.75 to firm X. Now let's see how this arithmetic works out. If you look at firm X, so firm X is receiving LIBOR plus 0.75 from firm Y, and it's paying that to the lending bank. So it's not out of the money there, the two are equal, and it is paying 10.5% to firm Y. So its net cost of borrowing therefore is LIBOR plus 0.75 minus LIBOR plus 0.75 plus 10.50, which gives a net cost of 10.5, which is what we had set out to do. Now let's look at what the cash flows are like for firm Y. It is receiving 10.5% from firm X. It is paying 10% to the bank. So it is in the money by 0.5%. 10.5 minus 10 would give you 0.5. It is also paying LIBOR plus 0.75 to firm X. So the net cost is 1050 minus 10 and subtract that 0.5 from the LIBOR plus 0.75. So the net cost to firm Y would be LIBOR plus 0.25, which is exactly what we set out to achieve. So effectively what we have achieved is X was able to borrow at fixed rate at 10.5% instead of 10.75 that it commanded in the market, and Y wanted to borrow at a floating rate at LIBOR plus 0.5. We have reduced its cost of borrowing to LIBOR plus 0.25. So both parties have benefited as a result of the interest rate swap. And this is the typical structure of an interest rate swap. Now I will give you another extension to this. These cash flows need not be exactly this. For example, 10.5 could be 10.25 and LIBOR plus 0.75 could be LIBOR plus 0.50. So even if these two cash flows changed, you will find that the effective cost of borrowing continues to be 10.5 for X and LIBOR plus 0.25 for firm Y. In other words, those two cash flows that we exchange between the two companies could be different as long as it delivers the same end result as the borrowing cost for the two firms. Now, in the real world of interest rate swap, there is a bank that is helping these two counterparties, firm X and firm Y, to come together and they structure the interest rate swap. Obviously, no bank delivers any service for free. So they would want to take a certain share of that 0.50, which is the effective benefit to the two firms. They'd want to share it between the two firms. Now how do they do that? If you look at the cash flows, it is 10.5. The bank takes away 0.05. So what flows out is only 10.45. Similarly here, this bank is paying 0.75. The swap bank swallows 0.05. So what goes out is only LIBOR plus 0.7. The rest of the MAC remain exactly as we saw in the previous slide, and because the swap bank is taking away 5 points each from the two banks, the effective cost to firms will be X will be 10.55 and borrowing cost for Y will be LIBOR plus 0.30. Remember, in the previous example, just to refresh, it was 10.5 and LIBOR plus 0.25. In the revised version, where 5 pips each is taken away by the swap bank, the effective cost will be 10.55 and LIBOR plus 0.30. It still is lower by 20 basis points when compared to the interest rate which X commands, which is 10.75. You managed to get it at 10.55, and Y commands LIBOR plus 0.5. It was able to borrow at LIBOR plus 0.30. So that was a pretty simple example of how interest rate swaps are set up in the marketplace. As would have been clear from the above example, an interest rate swap allows two counterparties to meet their requirements of borrowing, fixed rate versus floating rate, in keeping with their preference, at an interest rate lower than what they would command in the market. In the example that we saw, for instance, company X could source funds at a fixed rate as per its preference at 10.5% instead of 10.75%, and company Y could source funds at a floating rate as per its preference at LIBOR plus 25 basis points instead of LIBOR plus 50 basis points. Therefore, an interest rate swap enables both the counterparties to reduce their cost of borrowing by 25 basis points.